In today's session, we are going to discuss the complex problems on center of gravity and moment of inertia. Myself, Bipin Patil, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Dear friends, in this particular session, you may learn the center of gravity, how to calculate it, and the moment of inertia. Find the moment of inertia. Find the moment of inertia about its base. About its base. That base is nothing but AB is there. Of T section shown in a figure. First of all, you may read the problem very carefully. Whenever you are solving the problems, first thing that is very important, you may read it. What Daha given? Daha mentioned, you may find out the moment of inertia at base AB. And the section Daha mentioned, that is T section. Let's you observe the figure. What Daha mentioned in that particular figure. Okay, so the T section they are given. The dimensions, this is near about, you may consider 90 mm up to here. This is 30 mm. This is also 30 mm, and the total is 90 mm. Very simple thing is that. What is the next? Our task is very simple. You may consider the geometries separately. Now you may observe here two rectangles you may consider separately, or you may consider three. So I am considering this is the topmost portion. This is my first rectangle, figure number 1, and this is figure number 2 is there. Steps are very simple. What is your next step? Your next step is you may show the centroid or the both the figure. This is the G1, this is the G2. What is your next step? Your next step, they have mentioned the reference axis, that is A and B is there. And from this particular reference axis, you may calculate the moment of inertia. Now how to calculate it? What are the different steps are there? So your first step, you may calculate the area, right? So I am calculating the area of first figure, that is A1, area of second figure, that is A2. If I consider area, so this is 30 into 90 for first one figure. For second one also 90 into 30 is there, B into D is there. So if I consider base, so this is 30 into 90, here 90 into 30. So you will get the answer 2700 mm square. 2700 mm square. This is the area. Now the next step is that you may calculate the centroidal distances. So how to calculate the centroidal distances? Centroidal distances. So for that, you may consider the references. Now AB, from these references we are calculating. So definitely the mention, you may identify the moment of inertia at a base about EB. So here we are using the formula along the x-axis because A B is parallel to x-axis. So before that, you may calculate the distances, that is y1, y2 from a reference axis AB. So this vertical distance, let's you observe, this is nothing but your y1, this is nothing but your y2. Or you may calculate from top. You may calculate from top. Choice is your. This is first thing. Otherwise, the second method is there. So you may calculate this is your y1, and from here this is nothing but your y2. Choice is your. Okay. Now we are calculating from top, y1 and y2. This is for understanding. I have mentioned either you may consider from top, you may consider from bottom. This is your choice. So if I consider G2, so regarding this particular G2, you may calculate. So from top, if I consider this is your y1, so y1 is, you may consider this is the y1. If I consider figure number 1, y1 is half of this, that is 90 divided by 2. So you will get 45. 90 divided by 2, you will get 45 mm. Next one, you may consider y2 from top. 90 plus 30 divided by 2. y2 is equal to 90 plus 30 divided by 2. That is nothing but 90 plus 15. So you will get 105 mm. Okay, you have a choice. Either you may calculate from top or you may calculate from bottom. You will get the same. So how to calculate this centroid? Y bar is equal to A1 Y1 plus A2 Y2 divided by total area. So you may observe area of figure number 1, that is 2700 into Y1, that is 45, plus A2 is same 2700 into Y2, that is 105, divided by total area. So the total area, that is 2700 plus 2700. So do the calculation and try to identify the Y bar. You will get Y bar, that is from top. So after calculation you will get Y bar is equal to 75 mm is there. Total distance is 90 plus 30. So 90, then 100, 120. 120 minus 75, you will get Y bar from bottom. Clear? Now the Y bar is over. So you may identify the distances, that is H1 and H2 we required. How to calculate this H1 and H2? H1 is nothing but, suppose if I consider your Y bar lies here from top. So this small distance, this is your H1. And from here, this is the small distance, this is nothing but your H2 is there. Center to this particular centroid, and this centroid to the next G1, G1 to this distance, G2 to this distance. This is nothing but your capital G is there, that is centroid. So let's you observe, this is your H1 and H2. How to calculate it? So H1 is equal to, H1 is nothing but, this is your Y bar from top, Y bar from top minus Y1. So Y bar from top minus Y1, you will get H1. Y bar from top is 75 minus the Y1 is 45. You will get the value of H1. You will get the value of H1 30 mm. And simultaneously you may calculate H2. How to calculate the H2? This is the total Y2. Y2 minus Y bar. You will get H2. So Y2 minus Y bar from top. Y2 is 105 minus Y bar from top, that is 75. So you will get this distance is also 30 mm. Both the distances are 30 mm. Now you may calculate the moment of inertia that is along with AB. How to calculate it? So let's see, observe here. The geometries are same. Now how to calculate the moment of inertia? Moment of inertia of the AB axis of a T section is equal to moment of inertia of rectangle 1 plus moment of inertia of rectangle 2, that is BD cube by 12 plus A1 H1 square plus BD cube by 12 plus A2 H2 square. Please observe the figure now. For figure number 1, BD cube, that is B is 90, or you may consider this is 30 into 90 cube divided by 12 plus area. Area of figure number 1 already you have calculated, so it's 2700. So let's see, observe, this is 2700 into H1 already you have calculated 30 square. So do the calculation and try to identify the moment of inertia. This is for first part. Plus now I am considering here second portion. This is the B is 90, depth this is 30 cube divided by 12 plus area of second figure 2700 into 30 square. So by addition of these two, after calculation, you will get the moment of inertia of a T section that is along with the base, that is AB. So 30 into 90 cube by 12 plus A1 H1 square, and in addition with the moment of inertia of second rectangle, that is 90 into 30 cube by 12 plus A2 H2 square, and at last you will get the result 6.885 into 10 power 6 mm raised to 4. This is the moment of inertia of a T section about AB axis. So to prepare the video I have referred, these are the references. Thank you.